Hi, welcome to Competitive Cracker. I hope you people had a nice CSIR examination in this December, and I think you all are preparing for the next CSIR examinations, which is expected to be in June or July. So in order to help you in your preparations, we have come up with a small video comprising of some 4 or 5 questions so that it will be helpful for you for your preparations. So please prepare well. So Competitive Cracker is ready with the next batch, so that I am welcoming you all for this new batch so that we can study together. So let us directly move on to the questions. So see the first one. A small circular wire loop of radius a and a number of turns n is oriented with its axis parallel to the direction of the local magnetic field B. A resistance and galvanometer are connected to the coil as shown. When the coil is flipped, the galvanometer measures the total charge Q that flows through it. If the induced EMF through the coil EF is equal to IR, then Q is, this is one of the previous questions which was asked. So see, I will show you the diagram, then it is very easy to find out the answer. See, the question seems to be very long, but if you know the concept, it is very clear. Then the answer will be very easy to be solved. So let us find out the answers. See the answer. See this is the this is my loop. See this is my loop, and this loop is having a radius. The loop is having a radius a. So the loop is having a radius a, and this is the direction of the magnetic field, and the loop is flipped in this along this axis. It is flipped like this. Okay, the loop is flipped like this, and it is then connected to a resistance, and it is connected to a resistance and a galvanometer like this, and a galvanometer like this. See, seems to be a rheostat, right? So this is the figure, and we have to find out the value of the charge which is flowing through this galvanometer. Let us find out. See, so the coil is flipped means there is definitely a change in flux. So first, the change in flux. The change in flux. What is the change in flux? Change in flux is if it is in this direction, the area is in this direction, and B is in this direction. So it is a B dot A. It is a BA, isn't it? So BA, and change, it is minus. And if it is flipped, area vector is in this direction, B is in this direction. B will not change. So it is a B dot A means it is a minus BA. So it is a minus BA. So the change in flux is equal to 2BA. The change in flux is equal to 2 times BA. Clear? So the change in flux is 2BA. Therefore, we know the induced EMF. Induced EMF is equal to N into d phi B by dt. N into d phi B by dt. So induced EMF is given. It is I into R. I into R is equal to N into d phi B by dt. d phi B by dt. So if this is the case, we know the current I is dq by dt. Current I is dq by dt, or you can write it as if you assume that it is for a unit time, it is a delta q, isn't it? Delta q. So it is a delta q into R. Delta q into R equals, since it is for a unit time, I am assuming that N into delta phi B. N into delta phi B. Clear? So I am assuming that it is dq by dt. dt is assumed to be 1. So that or you can write dq into R is equal to N into d phi B. So instead of writing d phi B, I am writing it as a delta. Okay. So delta Q into R is equal to N into delta phi B. So then what is a delta Q? Delta Q is equal to N into delta phi B divided by R. N into delta phi B divided by R. Clear? So if this is the case, then delta Q is equal to, so then delta phi B, then what is a delta phi B? Delta phi B is 2BA. So it is delta phi B. Delta phi B is 2BA. So N into 2BA divided by R. Then what is A? A is it is a coil, it is a circular coil, and area is pi A square. It is a pi A square, isn't it? So the value of Q is equal to N into 2B into pi A square divided by R. And if you write it in a better form, the value of a Q or delta Q or the change in Q or Q, anything, Q is equal to 2 into N into B pi A square divided by R. So this is the value of the charge which is flowing through this galvanometer. Clear? So this question is very simple. So the only thing that you need to keep in mind is the production of induced EMF while you flip a coil. If you flip this coil, the direction of the area changes, so that the magnetic flux lines are cut, and then induced EMF is produced. The change in flux delta phi B could be written as BA. If it is in this direction, this is BA minus, if in the opposite direction, it is minus BA. So the change is 2BA. Then induced EMF is equal to N into d phi B by dt. So induced EMF is given IR. IR is equal to N into d phi B by dt. And if you assume that dt is equal to 1 for a unit time, then delta Q into R is equal to, because I is equal to, if you don't know, please write I is equal to dq by dt. dq by dt. And then delta Q is into R is equal to N into delta phi B. So delta Q is equal to this much. And then substitute for delta phi B, and then substitute for area, and then you will get the value of Q. Is it clear? So I hope you have understood this. So from electrodynamics you will get many questions, and also please pay more attention to Maxwell's equations, and also don't forget to revise your higher secondary classes. Okay, so the thing is, we are studying same electrostatics and same magnetostatics in higher secondary for +1 +2, and also for degree classes, and also in the same that same syllabus is repeated in PG also. Okay, so that much importance is that is having. So please do not forget to revise those electrostatics and magnetostatics before going for the examinations. It is very, very important. I think this is very clear to you. And let us move on to the next one. The dispersion relation of a gas of non-interacting bosons in 2 dimensions is E of k is equal to C under root k, where C is a positive constant. At low temperatures, the leading dependence of the specific heat on temperature T is, see, a dispersion relation of a gas is given, and it is given as E of k is equal to, the dispersion relation is given as E of k is equal to C under root k, C under root k, and we need to find out the dependence of specific heat on temperature. Okay, let us find out. So it is given as E of k is equal to C under root k. So we can say that here omega, the frequency is directly proportional to root k. Frequency is directly proportional to root k. Since frequency is directly proportional to root k, we know omega is proportional to k power n. Omega, if omega is proportional to k power n, here n is equal to 1 by 2. Here n is equal to 1 by 2, isn't it? So here, since n is equal to 1 by 2, we also have studied the relation of a specific heat. So the specific heat, in d dimensions, specific heat in here it is a 2 dimension, isn't it? So specific heat in d dimensions can be written as C is equal to the specific heat and temperature. C is equal to T power d by n. C is proportional to, or C is equal to T power d by n. So therefore here d is 2 and n is equal to 1 by 2, and n is equal to 1 by 2. Just substitute it, then what will you get? C is equal to T power 2 by 1 by 2, and you will get it as T power 4. Very simple. Only thing that you need to know is the specific heat the dependence of specific heat in d dimensions and temperature. Okay, this is the only relation that you need. C proportional to T power d by n. C proportional to T power d by n, where d is the dimensions and n is the value of the dependence of omega and k. Is it clear? So this is very simple, isn't it? So while you study this statistical mechanics, so very important. The statistical mechanics, you will get from statistical mechanics you may get some 3 or 4 questions, but the questions will be very simple. Like this, it is very simple. The only thing is that we need to pinpoint the correct relation. If you are able to pick out the correct relation by reading the question, then it is very easy for you. Otherwise it will be totally lost for you. So please study it carefully, and please practice statistical mechanics questions more and more, because they are of a very tricky in nature, and we need to get the idea by reading the question itself. Okay, so we need to do as fast as possible. So it is not possible to make ideas after reading the questions. While going through the questions, you should get the idea of how to do that question. Then only you can successfully defend the questions coming from statistical mechanics. Okay, by practice it will become very easy. Okay, so let us move on to the next one. See the next one. So see, Competitive Cracker has launched CSIR physics course for the upcoming examination, probably in June or July. Probably it will be by the end of June. So I welcome you all for this course. So this course has many, mainly the feature is this is an online course, so that you can practice from your home, from your comfort area itself. That is the main feature. Okay, so you don't have to suffer you don't have to get challenged by climates, or you don't have to be challenged by homesickness and so on. So you can practice from your room itself. So we will have daily activities for problem solving for physics, and you will be assigned to a mentor, so that he or she will take care of your progress, and your progress will be continuously evaluated. We will have a weekly exams, timetable based revision will be conducted, so that not from the very beginning itself we will be going according to the timetable. So you will be given a particular area for study for a particular week, so that and the weekend you will have an examination for assessing your knowledge for that assigned topic. Okay, and then you will have cumulative examinations, and also by the end you will have some for 4 or 5 model examinations also. Then you will be very well prepared for the examination. Then you will go and face the final examination, and there hopefully you will get better results. So this is our plan, and all syllabus will be covered. Okay, it is not like other coaching institutes. They are sticking on to there are some more other core topics, but here we are having all syllabus covered, and by towards the end of the course you will have extra live classes also. There we will discuss more problems, and you can clear your doubts there. Also you can clear your doubts by through your mentors, or directly you can contact the teachers through WhatsApp or through calls, or through any manner you can clear your doubts. The only thing is that you need to clear your doubts timely. Okay, so I think you have understood the specialities of our course. So I welcome you all, and please spread a word regarding our coaching, and regarding competitive cracker also. So I welcome you all, so that we can study together. Okay, so let us move on to the next. Let us move on to the next one. See, the Hamiltonian of a two-dimensional quantum harmonic oscillator is H is equal to px square by 2m plus py square by 2m plus half m omega square x square plus 2m omega square y square, where m and omega are positive constants. The degeneracy of the energy level 27 by 2 h cross omega is. See, they have not given what is the level, but they are given the energy, and we have to calculate the degeneracy of that particular state. Okay, so see, what is this? This is a two-dimensional quantum harmonic oscillator, isn't it? So this is a two-dimensional quantum harmonic oscillator. So so it is a two-dimensional harmonic oscillator. Two-dimensional harmonic oscillator. I hope you have studied this. So since this is a two-dimensional harmonic oscillator, what is the Hamiltonian? It is a px square by 2m plus py square by 2m plus py square by 2m plus half m omega square x square plus 2 m omega square y square, 2m omega square y square. So this is the Hamiltonian that we have got. So let us just reframe this Hamiltonian, and let us see. So H is equal to px square by 2m, no change, plus py square by 2m, no change. It is same as that of our general expression, plus half m omega square x square, half m omega square x square, same, plus I'm substituting half here. So it is half m into half m into 2 omega square into y square, half m into 2 omega square into y square. It is very crucial to change the given Hamiltonian into the Hamiltonian, the form of the Hamiltonian which we have studied. So now this is of the same form that we have studied. So from this you can understand that what is the value of omega x. Omega x is equal to omega, and what is omega y? Omega y is 2 omega, isn't it? So you got omega x is equal to omega, and omega y is equal to 2 omega. Clear? So for a two-dimensional harmonic oscillator, the energy nx ny is equal to nx plus half h cross omega x plus ny plus half h cross omega y. Is not? So just substitute the values. So you will get nx plus half h cross. What is omega x? Omega x is omega, plus ny plus half h cross. What is omega y? Omega y is 2 omega. Clear? So just take it inside. So that is energy E is equal to nx plus take this 2 inside, nx plus 2 ny plus half plus 1. It is 3 by 2 into h cross omega. So nx plus ny, so it is nx plus 2ny plus 3 by 2 h cross omega. Nx plus 2ny plus 3 by 2 h cross omega. What is this energy? This energy is given. They have given. What is that energy? It is 27 by 2 h cross omega. 27 by 2 h cross omega. Isn't it? 27 by 2 h cross omega. So, if this is the case, you can just cancel out h cross omega and h cross omega. then what is that? Then take this 2 here. So, it is 2nx plus 4ny plus 3 equals 27, isn't it? So, 2nx plus 4ny equals 27 minus 3 is 24, and you can take this 2 common and divide it, and then it will be nx plus 2ny equals 12. nx plus 2ny equals 12. So, we have to find out the values of nx and ny, which gives 12 as the answer. Okay. So, see, so we have got nx plus 2ny equals 12. nx plus 2ny equals 12. So, we have to find out the combinations of nx and ny which satisfies this relation. Are you ready? So, let us find out the combinations. See, you know nx and ny. nx has values 0, 1, 2, etc. ny is also having values 0, 1, 2, etc. So, let us find out what is the, I am substituting nx as 0, then ny will be, if you substitute to get 12, it is 6, isn't it? 0, 6, first value. Is it satisfying? So, 0 plus 2 into 6 equal 12. So, that is the first value. Then what is the second value? So, 0, 6. So, if I substitute 1 plus 2 into 6, so it will be nothing. So, next I am substituting 2. So, value of 2 plus, so this will be 10, isn't it? So, 2ny equals 10. So, ny equals 5. ny equals 5. 2, 5, isn't it? How to find? Just substitute 2 here. So, 2 plus 2ny equals 12. So, 2ny equals 10. ny equals 5. Clear? And then, what is the next value? 2. If you substitute 3, so 3 equals, so then 2ny equals 9. So, then 9 by 2, it won't be an answer. Then substitute 4. So, 4. So, 4, it will be 8. So, 2ny will be equal to 8, ny equals 4. ny equals 4. Next energy level. Next combination, not energy level, next combination. Then, if you substitute 5, then it will be 7. So, 7 by 2 can be the level. So, then substitute 6. So, if you substitute 6 here, so it will be 3, isn't it? So, 6, 3 will be another level. And if you substitute 7, so it is 5 by 2 will come. No, it can't be. So, if you substitute 8, so 8, 4 will be there. So, 8 and 2 will be another level, isn't it? So, 8 and 2 will be another level. And next, if you substitute 9, so 12 minus 9 is 3, 3 by 2 can't be. So, if you substitute next 10, so 10 and 1, isn't it? 10 and 1 will be another level. And if you substitute 11, no. If you substitute 12 minus 12 is 0, then 0. So, these are the levels which are possible, or which satisfies that condition. How many levels are there? 1, 2, 3, 4, 5, 6 and 7. So, what is the degeneracy? What is the degeneracy? Degeneracy is 7. Degeneracy is 7. I hope it is very clear. Okay. So, let us move on to the next one. So what is the next one? The Hamiltonian of a particle of a two particle system is H is equal to P1 P2 plus Q1 Q2, where Q1 and Q2 are generalized coordinates and P1 and P2 are the respective canonical momenta. The Lagrangian of the system is, see, they have given the Hamiltonian H is equal to P1 P2 plus Q1 Q2 plus Q1 Q2, isn't it? Plus Q1 Q2. So we have to find the corresponding Lagrangian. So that you should practice. Either you will be given a Lagrangian to find out Hamiltonian, or you will be given a Hamiltonian to find out the corresponding Lagrangian. So here you are given a Hamiltonian. So H is given. So then what is L? L is equal to summation over I Pi Qi dot minus H. So that is P1 Q1 dot plus P2 Q2 dot minus H, isn't it? So then what is that? So yes, then you have to find out Q1 dot and Q2 dot, isn't it? So what is a Q1 dot? So Q1 dot is equal to dou H by dou P1, So what is dou H by dou P1? Dou H by dou P1 is P2, and what is Q2 dot is dou H by dou P2, and what is dou H by dou P2? It is P1. P1. Clear? Okay. So you have got Q1 dot and Q2 dot. Then what is, just substitute it. So yes, so if you substitute it, Lagrangian L is equal to, so Lagrangian L is equal to just substitute. So P1, what is P1? P1 is or you can find out in terms of, in whichever terms, by seeing the options. Okay, I am doing in my way, so you can do by seeing the options. So L is equal to P1 into what is Q1 dot? That is Q1 dot. It is P2. Then plus P2 into what is Q2 dot? Q2 dot is P1 minus H. H is P1 P2 minus Q1 Q2, isn't it? So P1 P2 and P1 P2 cancels. So what is the answer? So it is, you will get P2 P1 minus Q1 Q2, P2 P1 minus Q2 Q1. So the thing is, but you have got this, but the options are not in this manner. The options are given in Q1 dot, Q2 dot, in that manner. So then you have understood that you have to replace P1 and P2. Just to replace P1 and P2 there, then you will get. So if you replace P1 and P2, so Lagrangian L is equal to, this is one of the correct answers. But so then what is P1? What is P1? P1 is Q2 dot. So Q2 dot into Q1 dot, Q2 dot into Q1 dot plus what is P2? P2 is Q1 dot into Q2 dot minus H. H is P1. What is P1? Is Q2 dot. It is Q2 dot P2. What is P2? P2 is Q1 dot. So it is Q1 dot minus Q1 Q2. So Q2 dot Q1 dot, this will be cancelled, and Lagrangian L is equal to Q1 dot Q2 dot minus Q1 Q2. So Q1 dot Q2 dot minus Q1 Q2. So that is the answer. Clear? So this is also the answer. If you replace P2 with the Q1 dot and P1 with Q2 dot, then you will get the same answer. Clear? So you should transform this according to the options. Okay, then you will, by seeing the options, you will get an idea of whichever constants that you need to substitute. Okay, either you need to substitute for p or you need to substitute for q dots, then you will get the idea. Clear? So I hope this is very clear to you. Then see the next one. The value of the integral I equals integral 0 to infinity e raised to minus x into x sin x dx. See, you will be definitely facing these kinds of weird integrals. By seeing those kinds of integrals, you will feel frightened. Okay, what type of integral is this? I have not seen this kind of integrals anywhere. I have not studied these kinds of integrals. Those people have not taught me. But if you look into this carefully, you will definitely see wonder. Okay, let us try to unbound these kind of integrals. Okay, see, you have studied Laplace transform. Laplace transform, isn't it? You will have definitely studied Laplace transform. So what is the Laplace transform? So Laplace transform of sin x. What is Laplace transform of sin x? What is Laplace transform of sin x? Integral 0 to infinity e raised to minus sx sin x dx, isn't it? Into sin x dx. Clear? So this is the Laplace transform that we have studied. So here since a is equal to 1, so Laplace transform is 1 by 1 plus s square, or 1 by s square plus 1. 1 by s square plus 1. A by s square plus s square plus a square. So that was the answer. A by s square plus a square. Since a is equal to 1, 1 by s square plus 1. So this is the Laplace transform in the S domain. Okay. So the domains also, please keep in mind the domains which we have studied is not, it's only arbitrary. Okay. It is not a constant. So the domains may change from a question setter to another question setter. The domains, the selection of domains may change. One may take T, another may take S. Don't be frightened. Okay, the thing is same. The concept is same. So you got the Laplace transform of sin as 1 by s square plus 1. So also the Laplace transform of, we also have studied x power n sin x. X power n sin x. What is the Laplace transform? Integral 0 to infinity e raised to minus sx into x power n sin x dx. X power n sin x dx. So this is equal to, this we have studied, minus 1 whole power n into d power n divided by ds power n of f of s. Isn't it? This also we have studied differentiation. Also we also have studied about integration also. So minus 1 whole power n into d power n by ds power n of f of s. So now, having these much weapons in your hand, just look into this. Just look into this integral. So this integral is I is equal to integral 0 to infinity e raised to minus x into x sin x dx. Sin x dx. See, x power n, in the place of n it is 1. In the place of s it is 1. N and s are 1. Then it is very easy to find out. Okay, let us find out. So f of s, so we got f of s is 1 by s square plus 1, and therefore this integral, since n is equal to 1, it is minus 1 whole power 1 d by ds of f of s. What is f of s? 1 by s square plus 1. 1 by s square plus 1. S is also 1, but wait, we will do. Okay, so minus 1 whole power 1 into d by ds of s square plus 1. So see, this is minus 1 into product quotient rule, s square plus 1 whole square, s square plus 1 whole square into s square plus 1 whole square into yes s square plus 1 whole square into 1 into so s square plus 1 into 0, s square plus 1 into 0 minus 1 into differential of this is 2s. So first term will cancel, minus into minus will be plus, so 2s divided by s square plus 1, 2s divided by s square plus 1 whole square, s square plus 1 whole square. Clear? So from seeing this, s is equal to 1, since s is equal to 1, so the value of integral I is equal to 2 divided by 1 plus 1, 2 square is 4. So the value of integral is 1 by 2. So the value of integral is 1 by 2. Is it clear? So we know the thing is, first we have to get the thought of, by seeing this integral, the thought of Laplace transform. What is the Laplace transform of sin x? And then what is the Laplace transform of x power n sin x, or x power n f of x? X power n f of x is minus 1 whole power n d power n by ds power n of f of s. Okay, this we know. This we know, already know. This also we know already. So if you have these two things in mind, and if you have practiced it very carefully, then by seeing this you can directly substitute s is equal to 1. So s is equal to 1, so minus 1 whole power 1, and n is equal to 1. It is x power 1. So since it is x power 1, minus 1 whole power 1, d power 1 by ds power 1 of f of s is 1 by s square plus 1. So apply quotient rule, denominator square upon denominator into differential of numerator. Differential of numerator is 0 minus numerator into differential of denominator, which is 2s. So minus into minus is plus, so you got 2s divided by s square plus 1 whole square. Then substitute for s is equal to 1, and you will get I is equal to 1 by 2. Is it clear? So the value of the integral, by seeing the integral you may get wonderstruck, but the end answer will be very simple. Okay, so you should practice more values of integrals like this. Okay, so this will be very simple for you. So only practice can save you. Okay, practice more and more problems as much as you can. So I wish you all the best, and I welcome you all to Competitive Cracker, and we will see you here, and we will see you with another video. Thank you.